Okay, so we're continuing to talk about correlation and causation. So, correlation just means that there's some kind of relationship between two different variables. Could be written in words, it could just be a graph. Causation means that one directly causes the other. So, the examples of those were smoking cigarettes causes lung cancer. Person falls and hits their head and gets a concussion. Another one, number of miles driven and the amount of gas used. The more miles you drive, the more gas you use. So all of those are causation. One that's confusing is age. So you just want to make sure you really think about this one. It says student with many absences and decreasing grades. So absences don't cause the decreasing grades. Not doing your work causes decreasing grades. If you don't turn in missing work, if you don't do late work, if you don't do the test that you missed, anything like that, that's what causes your grades to decrease. Because some people could be absent all the time, but do their assignments and their grades are good. Let's go to the next page where we have some scatter plots. So we did types of correlations yesterday with positive, negative, and no correlation. So if we look at this one, the trend or the pattern is going downhill. So it is a negative correlation. And then the words weak and strong mean, does it form a line? Is the pattern close to a line that's going downhill in this case because it's negative? So if I were to draw a line here, not all the points they're not really close to that line. They're not clustered together. So the more clustered they are together, the stronger it is. So these aren't clustered together. So it's going to be more weak than strong. Strong means it forms a straight line. So let's make a conclusion about our graph. So we have two different variables. We have driver age in years, that's our x variable. And then our y-axis, it says sign, legibility, distance. And so what this actually is like your signals. Your blinker left and right. Has anybody taken driver's ed yet? Or started to? Nobody started it yet. So whenever you start taking driver's ed, they tell you all the rules. So it's fresh in your brain. So when you start driving, you know that you're supposed to turn your blinker on so many feet. I don't even know what the feet is, but so many feet ahead of where you brake and ahead of where you turn. So that it lets the person behind you know that you're turning so you don't surprise them and then they end up hitting your back end. So you want to sign or do your blinker in enough time that the person behind you knows. So when you first go through driver's ed, you know that information. You are making sure you're doing it. People are watching you because you have to do that training, right? You have to do so many hours with a parent in the vehicle where they're telling you whether you're doing it right or wrong and correcting you. So you're doing it right in the beginning. But as you get older, what do you notice about the distance of putting that blinker on? It's going down. It's not as much of a distance because people get lazy. People decide that they don't need to do it anymore. They don't think it's important. Maybe they haven't got the ticket for it yet, so they're just not going to do it. Or they just do it right there at the end. So basically, laziness causes that. So what we can conclude about this data is that the older you get, the less likely you are to put on that blinker. So as a driver gets older, the signal distance decreases. So that's how you could describe that data. Let's go to the next one. The data represents which type of correlation? What do you notice about the scatter plot? Which direction is it going? Up, so it's positive. We want to know whether it's weak or strong. If we were to draw a line through this, would it be close to a straight line? All the points? I'd say it's pretty close to a straight line. So this is considered strong, way stronger than the last one. So what can you conclude about the data? So you have to identify what the variables are. So we have X here, Y here. So X is height, Y is arm span. So as someone's height increases or the taller you are, what do you notice about the arm span? Yeah, so they both increase. So the taller you are, the longer your arm span. And if you look at these, look at the first one, see that's 100. The arm span is a little bit above 100. This one's 120. Arm span's 120 and 140. Those are two different data points or two different people. This one's 130, close to 140. 140 is close to 140. 160 is close to 160. They're actually about the same, right? Have y'all ever heard that? Your height is the same as your arm span. If you expand your arms like this and turn, it should be your same height. Have y'all ever heard that? Yeah. We might do some measurements next week about that and see if that's true. All right, let's go to correlation coefficient. So correlation in algebra. So we can describe it in words, but we can use our calculator to describe it as an equation and as a value that tells you how weak or strong it is. So linear regression, we've already learned this, where we put in L1 and L2, and then we do linear regression to get our equation. It comes up with the line that fits that data. And it's written as y equals ax plus b. So a is our slope. And b is our y-intercept. And next week when we do this lesson about linear regression, we are going to graph the equation that we get on our linear regression on top of a scatter plot in a graph and see how closely it fits the data. So it's called a line of best fit. Whenever you put a line on top of a scatter plot, it's called the line of best fit. And we can find a number, it's called R, where it tells us the strength of a linear relationship. So put a little star right here. Correlation coefficient is the word. Numeric value that assesses the strength of a linear relationship between two variables. We use the letter R. It assesses the strength, so whether it's strong or weak. So R is the letter that describes it. So when we do linear regression in our calculator, it'll give us R. But we don't look at R squared, we only look at R. R is another value. R squared is another value, but R is the one that tells us whether it's weak or strong. So this number line tells us where a number would fall, whether it's weak or strong. So 0 means zero correlation or no correlation. It's weak anywhere close to the 0. Then as you go to positive side, that's a positive correlation, so it's going uphill. But it's also getting stronger the closer you get to 1. You can go to the left of the 0, and you're going to the negative side, and that's a negative correlation. So the dots on the scatter plot are going downhill, but the closer you get to -1, tells you that it's strong. So closest to 1 and -1 are strongest. So it doesn't matter if it's positive or negative on strength. That just tells you whether it's positive or negative. But the closer it is to 1 and -1 means it's strongest. So these two examples, they put the following correlation coefficients in order from weakest to strongest. So the weakest ones are close to 0. The stronger ones are close to -1 or +1. So let's look at these numbers. The weakest one would be the closest to 0. If we look at it, 0.07 is the weakest. So we're going from weak to strong. The next one would be 0.43. And then -0.81. Because remember, the sign doesn't matter for weak or strong. -0.81. And then 0.87. And then -0.98. So -0.98 is the strongest because it's closest to -1. Okay, let's look at the second example. Go ahead and list those in order from weakest to strongest. And we'll check it. So the smallest number is at 0.04. That's the one that we do first. That's the weakest. And then 0.32, -0.42, then 0.63, and -0.65. The -0.65 isn't super strong, but it is the strongest out of that group. Okay, the way correlation looks in a scatter plot is what we're going to look at next. There's the scatter plot. All the dots are really close to that line. That line's called the line of best fit. It's not going to be exactly 1 because exactly 1 means all the dots fall on the line. But I think close to that will be 0.98. So approximately, see how it has a squiggly equal sign? That means approximately or about. The next one, it's more spread out. So it's going to be a little bit weaker. So it says weak positive correlation. So I'm going to say this is close to 0.6. It's not close to 0 because 0 is everywhere. This one we know for sure it's going uphill. It's just not on the line real great. Okay, the next one, it's close to the line, but it's more spread out than that first one. I'm going to put 0.95. And these are just estimates. The next, oh, but shouldn't this say a negative? I forgot that. Put your negative there because it is a negative correlation. So the R value will be negative. This one's also negative, but it's a little bit weaker than this one. But this one is weaker than this one. So I would say a -0.7 would be a good R value for that. This one's also negative, but it's more close to the line than the last one. So I'm going to put that as 0.8, -0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. 0.8. And the last one, it's all over the place. So it's very weak, no correlation. So it's going to have a 0 R value. That means there's no correlation at all. So you have an assignment. There is one that I wanted to go over with you. It's on the back. I'll show you it, or I'll pass them out in a minute. Positive, negative, or no correlation. The one I want to go over is number 8. Your age and the cost of insurance for your vehicle. Y'all know much about car insurance? Have your parents ever talked to you about whenever you first start driving and your insurance? It's so expensive when you first start driving. But I think once you turn 21, it goes down. Once you turn 25, it goes down. So if we have your age and the cost of insurance, as your age goes up, what's going to happen to your insurance cost? It's going to go down. So that is a negative correlation. Okay. On the front, all that this is asking is it correlation or is it causation? Remember, correlation means there might be a relationship, but causation means one directly causes the other. So correlation ones are kind of like the funny ones. They make no sense. Like the first one, increase sunlight and math test scores. So if you get more sunlight, your scores go up. Does that make sense at all? No. So it's kind of a silly one. So it's correlation. But if there's one that directly causes the other, then that would be a causation. Okay. At the end, once you answer these questions, you're going to see if you got the riddle right. It says, who is the world's most famous French fictional law officer? So once you finish answering these questions, what it says is print those from the column marked correlation down at the bottom. So you're going to go through and you're going to write all of these letters that you chose down here. And then you're going to write these letters. So go down this column and then down this column, writing these letters down here. These mean there's a blank. Okay. Once you finish, you can turn it in.